All right, so today you gathered some data with different bridge lengths. The lesson before this was with different bridge thicknesses. So today was the lengths. And I'm going to write my data up here. You're going to keep your data and analyze your data compared to my data. All right, so we're going to make a graph. So we're going to put length and weight, and the title is going to be Bridge Break. And I think yesterday there was, I think I was saying length, and the whole last lesson should have all been thickness. I should go look at that. Okay, so we're going to plot that. Over 4 up 42, put a dot, or you're plotting your data. So I'm plotting my 6 point, I'm plotting my 8 point, and plotting my 9 point, and plotting my 11 point. Oops. Alright, so the first thing you want to do is analyze to see, is this linear? So if it's linear, when you subtract the last number minus the previous number, you get something pretty close to each other, within a few. So 14 minus 16 is actually negative 2. 16 minus 19 is negative 3. 19 minus 26 is negative 7. And 26 minus 42 is negative 16. So this is getting bigger and bigger and bigger as you go back. It's more and more negative. So this is not linear. So not linear, because the first difference is not similar. So the next thing that you're going to see if works is you're going to see if x times y gives you the same number or close to the same number. Re-put my title. So again, first you check to see if it's linear by subtracting. Now you're going to check to see if x times y gives you the same exact number. So 4 times 42, I'm going to grab a calculator, is 168. 6 times 26, I'm multiplying these two, is 156. 8 times 19 is 152. 9 times 16 is 144. And 11 times 144, 11 times 14 is 154. So if you look at this, it's kind of sort of close. Not perfect, but it's closer in proximity than the linear. And also, if you wanted to try a best fit line, this definitely looks more curved. As you're going back, it's getting more and more and more, and as you're going down, it's becoming closer and closer to the same, very flat. So this is looking like something called a hyperbola. And a hyperbola is an inverse relationship. That means as x goes up, y goes down. The opposite thing is happening.
Diane Modem, if you're in the building, please report to the guidance office. Your ride is there. Diane Modem, the guidance office, your ride is in the guidance office area. Thanks.
Okay. And since something is probably a hyperbola, that means that when you multiply the two numbers, you should get the same exact number or close to it. So we can take the 168, 156, 152, 144, 154 and average them. So if you add 168 plus 156 plus 152 plus 144 plus 154, you get 774. And then there were 1, 2, 3, 4, 5 numbers. So if you divide that by 5, your average is 154.8. So we can write a little equation for this, which is x times y equals 154.8. And you can solve for y, isolate the y, by dividing both sides by x. So y is equal 154.8 divided by x. So the relationship is as x goes up, y goes down by less and less. It's a hyperbola. So now we're going to predict for 3, 5, 10, and 12. All right, well, 3. So the question is 3 times what? I'm going to put 5, 10, and 12 in before I forget. 3 times what will give you 154.8? So if you do 154.8 divided by 3, you get 51. So that'd be a good approximation. Now let's actually think about this more logically. You've got your 2 tables or your 2 books. This is what you did in class. You've got your paper that overlaps 1 inch. And this is 1 inch. So if this piece of paper is only 3 inches, all you have left in the middle is 1 inch. And then you have that cup. And I believe that cup's base is more than 1 inch. So basically this cup is going to end up resting on the table. So at this point, this data is no longer accurate because it's not suspended on the paper. All right, but we can predict for 5, 10, and 12. So to predict for 5, we're going to do 154.8 divided by 5. Or, you don't have to be this exact. So this is about 30-ish. You can look and see what's between 26 and 42. And you can also go down here to number 5, trace it up, and trace it over. So this is like 27. So anywhere in there is fine. 10, if you want to go to 10 and trace it over, it's going to look like 10-ish. Actually, that's just kind of a low graph. It looks between 16 and 14 is 15. And if you do 154.8 divided by 10, you get 15.4. And then 12 is probably going to be, since this is going down by 1, it's probably going to be 13-ish. Again, my graph's a little low. And if you do 154.8 divided by 12, you would get 12.9, which is super close to 13. So those are really good predictions. You can predict by guessing in the table, by following the graph, or by using your new equation. So how is this the same and how is this different than what you did before? So it's different because before we did thickness of paper. And the more paper, the more pennies. And we got a linear data. where the graph was going up. This activity was on length. And the longer the bridge, the less pennies it held before it broke. So we got some data that was going down, and it was a curve. So that's a lot of ways it's different. And how is it similar? Well, both of them had bridge breaking. And that is the same question. So, to actually write a problem up here that I want you to try. So you're just going to copy this down on your paper. And the problem is that you have a crane. So you know, like those cranes that have this like thing and they pick up like big heavyweight concrete. Okay, you do. So this is construction crane data. And the data is the distance from the cab to the weight that it's carrying. So like the cab, I think there's like a little thing that this person sits in and they operate it. It's super fun. And then so that would be this distance from the cab to the weight that it's carrying. And then the actual weight. So this is in feet. Okay, so 12 feet away, the weight is 7,500. 24 feet away, the weight is 3,750. 36 feet away, it's 2,500. 48 feet away, it's 1,875. And 60 feet away is 1,500. All right, so the first thing I want you to do is think, what is the relationship here? So, is this linear? So, if you want to know if it's linear, you're going to subtract. 1,500 minus 1,875 is negative 375. 1,875 minus 2,500 is negative 625. 2,500 minus 3,750 is 1,250. So this is definitely not linear. So we're going to scrap that whole idea. Now we're going to see if it's a hyperbola. So we're going to see if x times y gives you the same exact number. So 12 times 7,500 is 90,000. And 24 times 3,750 is 90,000. This is kind of exciting. 36 times 2,500 is, You guessed it, 90,000. 48 times 1875 is 90,000. And 60 times 1500 is 90,000. So our equation would be x times y is always 90,000. And if you want to isolate that for y, because that's how you write an equation, you would divide both sides by x. So y equals 90,000 divided by x. If you were to graph this, it's going to look just like our other hyperbola where it comes down and flattens out. So it's less and less and less of a difference as you go this direction. And let's do a couple predictions. We'll predict 18, 30, and 72. So I want you to pause right now and see if you can get those three answers and then come back to me. Okay, so if 18 is our x value, 18 would go in for x. So 90,000 divided by 18 is 5,000. So we got that by doing 90,000 divided by 18. Again, we do the same thing with 30. This would be 90,000 divided by 30. You'd get 3,000. And then 90,000 divided by 72 would be 1,250. So if you had your graph perfectly graphed with labels and titles, these numbers would already be on that line. Like you wouldn't have to be adding any numbers because they're on this best fit curve, not line. They're on the best fit hyperbolic curve. It's a hyperbola. As x increases, y decreases. All right, that was some deep stuff. Now, you have a homework packet, the one that you got yesterday, so I want you to try to do the back page of that, the very back page. So the day before this, you did the first, second, and third page, front, back, front. Now you're going to try to do the last page right this second, and we'll go over that tomorrow. All right, have a lovely evening.